Let's see this question. It is about token ring again. So consider a 10 Mbps token ring, which means bandwidth is given as 10 Mbps, and token ring is used in a LAN with a ring latency of 400 microseconds. So here they are directly giving us a ring latency. So whenever they give us ring latency, don't use propagation delay, you directly use ring latency. A host that needs to transmit, which means if a host wants to send a packet, seizes the token, which means it will take the token, then it sends a frame of 100 bytes, which means size of each frame is 100 bytes, and removes the frame from it, and removes the frame after it has circulated all around the ring. So what does it mean? Let the token take the entire frame, take the entire round, and then once it returns, it is going to remove it from the ring and finally release the token, which means we are going to delete the token from the ring, the frame from the ring, and after that we are going to delete it. This process is repeated for every frame. So we are going to repeat the same process for every frame. Assuming that only a single host wishes to transmit, the effective data rate is. So what is that they are saying is, this entire strategy is nothing but delayed token reinsertion, which means a station will take the token and then send the frame and let the frame come back, for which we are going to wait, and after that we are going to release the token, which is nothing but delayed token reinsertion, not early, sorry, it is delayed token reinsertion, right? So what they want is the effective data rate. So we know that effective data rate is nothing but effective bandwidth, which is efficiency into bandwidth. So in order to solve this question, we should first find out the efficiency. So in order to find out efficiency, we should find out A. See this, ring latency is given as 400 microseconds, and TT, transmission time, is L by B, length of the size divided by bandwidth, which is 80 microseconds, and then A equal to ring latency by TT. So whenever TP is not given, whenever RL is given, ring latency is given, always go for it. So A is ring latency divided by TT, which is 400 divided by 80, which is 5, and efficiency is 1 upon 1 plus A into 1 plus 1 by N. And they have even said that only a single host wants to transmit, which means even though there are other hosts, only a single host is continuously sending the data. So it is as good as taking N as 1. So other all hosts are just listening, they are not doing anything. Therefore let N be 1. So in case if N equal to 1, we got the efficiency as 1 by 11. Then what is effective bandwidth? Efficiency into bandwidth, which is nothing but 1 by 11 into 10. So it is not actually 1, it is less than 1, but then it is close to 1 Mbps. In the options, you have 1 Mbps, 2 Mbps, 5 Mbps, 6 Mbps. Actually it should be 10 by 11, which is very close to 1. So there is no other option which is close to 10 by 11 other than 1 Mbps. So the answer is A. A is the answer, and this is how you should be solving this question.